The Autodesk Inventor stress analysis environment contains tools to analyze individual components as well as assemblies to see how they might react under real-world conditions. Users can apply various loads and constraints to the model to predict premature failure and determine if the model is overbuilt. Along with the boundary conditions, users have granular control over global mesh size and localized refinement to focus around critical areas of the design. Once the simulation is complete, the model may be inspected using color gradients and point-specific probes. Simulations may be duplicated and modified to analyze different materials and loading conditions for a full comparison and final decision-making. The addition of convergence studies makes sure that the final simulation runs have maximized accuracy and minimized the margin for error. Based on the materials and boundary conditions, the Modal Analysis environment can evaluate parts or assemblies for vulnerability to natural frequencies. Users can inspect the results and see just how each frequency will induce movement in the components. Once the desired results are achieved, the integrated report generator can quickly and easily generate a starting point for a full technical report on any set of analyses performed within the model. Users can customize the output to include input parameters as well as iProperty information, and choose which results images need to be generated for the document. The report can then be completed and modified to fit company standards. The final piece to the Inventor stress analysis environment is shape optimization. In this environment, Inventor provides critical feedback regarding the pathways that stresses propagate through the component's material. A mesh is generated, indicating the areas where stresses are highest within the model and where material can be removed to reduce weight while maintaining a strong component. This mesh can then be promoted back to the model to guide engineers as they modify the design according to the shape optimization results. As before, this now optimized model can once again be put through the stress analysis environment to view the final outcome of the design changes.